Okay, you asked to do table and graph for each of these functions, and yeah, looking at the results, people are doing kind of okay with this, but at this stage we should be able to make the table and graph of any of these 5 functions without asking what x values we use. They're always the same, and if you practice these and do them, say every day, until you can do all 5 of them in a minute, and you really should do that, and should have done that by now, because everything we do, or much of what we do, most of what we do, is going to reference back to these functions. And if you don't know this information well enough to write it down in a minute, you're not going to understand a lot of what you're saying. So it's very important for you to do that, plus it counts. So keep asking. Okay, so you do the table and the graph for this thing anyway. Now, from y equals 1 over x, you get the table. And I'm not going to do that. Okay, again, I assume you know what that table is. I assume you can figure it out in 10 seconds or less, and I assume you can graph it in another 10 seconds, okay? That you immediately understand this function, know what the values are, know what the graph looks like and why. The graph of y equals 1 over x. 3 points look like this. Here, and then you have 3 points here, and you have an undefined value at y equals 0 because of division by 0, which is going to indicate that you have vertical asymptotes there, and there are other things that you know. However, just focusing on the 6 points that you get, the 6 points that you plot when you do this exercise, this necessary exercise you have to be able to do in a minute, you get these points, you get that graph pretty much immediately, and you know the coordinates of the points to be -2, -1/2, -1, -1, -1/2, -2, here, here, and here. And these coordinates similarly, 1/2, 2, 1, 1, 2, 1/2, you know where those come from, and you know what they are. And you recognize them when you see them. Okay? So that's the set of points that we graph from our table. Now, if we regard our function as just those points, okay, just those x and y values, and we can do that. That's a perfectly valid function. Then the function is this set. It's the set of these 6 points. Now that's not the entire 1 over x function for all values of x in the domain, but we'll talk about that in a minute. Okay, for this set of points, the domain of this set, and this set does constitute a function, the domain of this set is the set of x values, -2, -1, -1/2, 1/2, 1, 2. The range is the set of your y values, -1/2, -1, -2, 2, 1, 1/2, if we write them in the order they appear here. But of course, any set, and the range is a set, as is the domain, can be put into any order that makes sense to us, and usually we're going to list range from least to greatest, from -2, -1, -1/2, 1/2, 1, 2. Now, these could be in any order, these could be in any order, so the order of these cannot be expected to follow the order of these. But in this case, actually, it does, because the members of your domain are the same as the members of your range. They don't occur at the same points, but they all occur. Okay, now we, of course, then can extend the graph. Now the purple graph, it starts here, it ends here. And this purple graph starts here and ends here. And at this point, we include the graph point, the point that we plotted, the point 1/2, 2. Okay? At this point, the point here that we plotted is 2, 1/2, and we don't include that, and we indicate that by a circle around the point. Okay, not included. And neither of these points is included, but every point between them is included. So that we say the domain, as pictured, is the set of all x values. Well, we have all the x values from here to here, from -2 to 1/2 except we don't have -2 and we don't have the 1/2 because these points aren't included. That means the domain is the open set indicated by parentheses from -2 to -1/2. Okay, at least this part of the domain is this open set, this open parentheses set, the parentheses set, -2 to -1/2. And then it's the total domain of the pictured function, of course, includes the domain for these points. So we're going to express that as a union with this set of x values. And the x values here start at -1/2, okay? And they include -1/2. And they go up to 2, but they don't include 2. And that means we write this as bracket 1/2 2 with the parenthesis after the 2 because 2 isn't included. Okay, now we could do the yellow graph, okay, where we extend this graph as far as it will extend. Now, the one thing that we can't do with the graph is we can't extend it through x equals 0. We have it on one side of x equals 0, have it on the other side of x equals 0, but we can't include x equals 0 for the same reason that the x equals 0 point was not included in this set. That is, the division by 0 is undefined, so if x equals 0, y is not defined. 1 over 0 is not defined, so you don't have a y, so you don't have a point. So that x value isn't in the domain, and there's no y value in the range that corresponds to it. We'll talk about range in a minute. So for the yellow graph, x can be anything but 0, so the domain is what? Anything to the left of 0, anything to the right of 0 on the x-axis. That's the interval from -infinity to 0, and then from 0 to infinity, but not including 0. And we write that this way. The parentheses here because we don't include 0, the parenthesis here because we don't include 0, and the parenthesis in -infinity and infinity because we never get there. Okay, we go as far as we want, we never get to infinity, so we can't include -infinity or infinity in our domain. -infinity and infinity are not real numbers. -infinity and infinity are things that we can approach, but we don't reach. Okay? So they're outside the domain of real numbers. Okay, well, that's the domain of this function. Hopefully you understand that. If you're in the MCR, we looked at it again and found that people didn't understand the graphs as well as necessary to build on them. So we nagged them a little bit about that. So, you know, make sure we don't have to nag the whole class about it. Okay, learn these graphs. You're not going to learn what we're doing unless you understand these graphs. And this is just a matter of practice. If you can't do these graphs in a minute each, you haven't practiced enough, and you have to practice. Can't emphasize that strongly enough.